Hey guys, welcome to another video. Today's learning objective is use positive integer powers and associated real roots, recognize powers of 2, 3, 4, 5, and estimate powers and roots of any given positive number. As usual, feel free to skip to any part of the video, the timestamps are here. Thanks to the magic of post-production and editing and our great video editor, thank you. So, okay, let's talk a bit more about kind of the learning objective and kind of what the prerequisite knowledge is. Well, a quick question is, do you know what something like, say, 2 to the 4 equals? Can you tell me, say, why it equals 16? So that's kind of a really important question to have. But as a brief reminder, what this power means is saying 2 to the 4 is the same thing as writing, kind of, thanks to our mathematical notation. It just means that it's 2 times 2 times by 2 times by 2. And when it's, say, a number x, say, to the power of a, what it's saying is you multiply x by itself a times. And this is just mathematical notation, that's all it is. So, kind of, an example will be, say, 3 squared, which is 3 times 3. So yeah, that's what powers are, just a kind of a brief reminder. And then, real roots. Okay, well, first off, just a quick question, do you know what, say, square root of 4 is? The answer is 2, but do you know why? So, again, brief reminder, what a square root means is that it's asking what number times by itself gives me the number in here. Well, the answer is 2 times 2 gives me 4. So the square root of 4 must be 2. But at the same time, when you have, say, the square root, you can also have the cube root of, say, for example, 8. And now this is asking me what number times by itself 3 times gives me 8. Think a minute to think about what this might be. The answer is 2. So how did I know this? Well, it's almost kind of a kind of memorization. You kind of it's mental math, and you kind of have to learn these things about what the kind of cubes are, and also a bit of trial and error if you forget, for example. So the cube root, like what number times by itself can equal 8? So I can try 1 times 1 times 1 just is 1. Yeah, I can try 2 now. 2 times 2 times 2 is 8. So I kind of stumble across it. So if you would try another one, say for example, cube root of 27. Ooh. Well, okay, I know it can't be 2 because that's that. So let's try 3. 3 times 3, 9, 9 times 3, 27. There we go. So, is that 27? 9 times, yeah, 27. had to check myself there. So it's kind of just a bit of memorization in that. And so the way you can have cube root, you can also have kind of the root, like say the 5th root of any number, say 32 for example. So again, you can try 1 times 1 times 1, that doesn't work. Try 2, that works out. 2 times 2 times 2 times 2 is 32. So it's kind of, the way to figure these out is not kind of, it's a bit of trial and error, a bit of kind of estimating what number it might be, and a bit of memorization as well. So that's what kind of these roots mean. And you need to know kind of, say, that this is called a square root when there's a 2 here. You don't write the 2, but that's what kind of if there's nothing there, it means there's a 2 effectively. And when it's a 3, it's a cube root. But above that, it's called, say, like 5th root, for example. So, and then now you have to say another thing is to recognize powers of 2, 3, 4, and 5. So what this kind of means is that you should kind of know, for example, 2 squared is equal to 4, and 3 squared is equal to 9, and even cubes, say 2 cubed is equal to 8, and kind of same with 4 and 5. So you know what is a really good exercise right now is to say, for example, get a piece of pen and paper out, and just scribble down, say, 2, 3, 4, and 5, and say do 2 squared, and just figure out what these are, say, and then 2 to the 3, and then 2 to the 4, and then even 2 to the 5 if you're feeling brave. And the same thing with 3, 4, and 5, kind of down here. So just take a few minutes to do that. It's just important because next time you see them, you'll be able to recognize them, and a lot of the times some questions require you to kind of recognize these. So it's quite helpful to know them and just be able to recognize them. So let's move on to our first question. I promise we'll get back to estimating powers and roots. So let's get on to the first question. It's to evaluate root of 144. some of you guys might just recognize this as 12 squared, so you can answer that as 12 if you know your mental math quite well. But if you don't, then there's actually a kind of a way to think about it and go about doing this. So I can try, for example, every number from 1 to 12, but that will take a while. But for example, I know 144 is greater than 100, right? So, and I know 10 squared is 100. That's something I think kind of everybody will remember. So I know I have to try numbers above 10 at least, right? So I can try 11 squared. Okay, 11 times 11. Perhaps you're not sure, you can get out your kind of cross multiplication and try that out. That's 121. So it's not 11 squared. Okay, let's try 12. Well, 12 squared works out. So we know it's 12. And then kind of that's my point before about how you kind of need to recognize some of the roots, some of the powers. So now estimate the square root of 60. So a really good way to go about estimation is thinking, what's this number less than and what's this number more than? Well, since it's root 60, which is it's a very bad looking 60, I can't lie. Let's scribble that out. Switch it back to my pen. So look, it's the square root of 60. So what's the square root of 60 less than? Well, it's less than, say, the square root of 61, for example. We know that much. But that doesn't really help us that much because we don't know what the square root of 61 is. Well, what's a square root that we do know that's kind of around 60? Well, we know the square root of 64, right? That's a perfect square. And the square root of 64 is 8. So we know root 60 is less than 8. Now think about what root 60 is more than. And let's go back to our perfect squares. Well, if you kind of done your mental math and you remember your mental math, you know that the square root, so sorry, actually, since you know this A, you can kind of guess 7. 7 squared, 49, right? And that's less than 60. And if you know your mental math, you know that there's not a square root between kind of perfect square between those two. So it's less than root 49. So you know root 60 is less than 8, but more than 7, right? So you know it lies somewhere between 7 and 8. Now you need to estimate kind of which side does it lie closer to. Well, 60 is closer to 64 than 49, right? So it's probably more than 7.5. And it's fairly close to 64, so you can estimate something like maybe 7.8. So since that, and again that satisfies, it's between 7 and 8, right? And so you can estimate, so our answer might be, for example, to estimate 7.8. And a lot of the time these questions kind of have a range involved, an acceptable range for answers, because without a calculator it's pretty difficult to actually estimate this properly. So it's quite important to kind of just think about what this number is less than and what this number is more than. And when you do that, make sure you think about a perfect square, so you can kind of tell between which two whole numbers it lies between, and then narrow it down, saying, oh, it's closer to this whole number than this other whole number. So that's kind of the way to approach these things. Kind of to kind of consolidate this, perhaps it's kind of worthwhile to try out another one. Say, what's the square root of, red pen. What's the square root of 99, for example? I'll give you guys a minute to try figuring this out. Did you give it a go? No, I know you didn't give it a go. No, go on, give it a go. Did you get, okay, cool. You're back? Okay, cool. So, again, which perfect square is this less than? Well, it's of course less than 100, right? Which is 10. But if 10 is here, then we know kind of 9 squared is 81. So we know it's greater than root 81. So we know it lies between 9 and 10. But root 99 is so much closer to root 100 than root 81, right? So we can estimate something like, say, 9.9. Because it's so close to, 99 is so close to 100 that we should estimate really something on the far end, a lot closer to 10. So that's kind of another example. Hope that kind of helped. Today we kind of talked a bit about what roots and powers are, and how the importance of being able to recognize different roots, and as such kind of having your mental math, kind of really knowing it, and giving it a bit of practice. And then we also talked a bit about estimating roots, which can, honestly, it is a bit tricky, but kind of the only way with math, you'll hear me say this like every time now, but it's really important just to practice, because that's the way you can improve at math. So thanks very much for joining me this time around, guys. See you in the next one.